I'm standing here next to Barca Dam, a massive concrete structure that's nestled at the top of a canyon about 2,500 feet above the city of Boulder in Colorado. This critical piece of water infrastructure is almost 200 feet high and 700 feet wide and holds back a reservoir that contains 12,000 acre-feet of water. Water that's flowing down from the melting snowpack in Indian Peaks behind me is gathered and stored here to supply the city of Boulder with a reliable source of drinking water throughout the year. Just give you some perspective, Boulder has about 100,000 people, and this reservoir provides 40% of the drinking water. In this lecture, we'll be exploring the ambitious water infrastructure that was designed to bring water to the West. We'll learn how water has been pumped uphill, transported across deserts and over mountains to satisfy the evolving and growing thirst of the American West. We'll start with a summary of the important milestones of infrastructure development to understand how we got to where we are today before we look into the future. New opportunities is what the early settlers of the American West were looking for. Following the passage of the Homestead Act in the late 19th century, settlers moved west to claim the 160 acres that were promised to anyone who would work them for 5 years. But as we heard in earlier lectures, the West only receives 20 inches of precipitation or less, which is too little for most crops. And that's just an average. Individual years can be much more dry. So the only successful way to farm this land was to build irrigation channels. But farmers had to not only cope with too little water, rivers were often flooding unpredictably, inundating low-lying lands and further challenging farming. So in addition to irrigation channels, farmers had to build flood control infrastructure. Irrigation was not a new concept in the West. The first irrigation systems in the western US were built by people from the Hohokam culture, which lived in the region that's now the Phoenix area. Between 300 and 1400 AD, Hohokam Indians built networks of irrigation channels to water their crops. The next pioneers in irrigation systems were the Mormons, who developed large and extensive irrigation channels and dam systems when they settled Utah's Salt Lake Valley. A lot of their levees and channels were dug by hand using simple tools, an enormous accomplishment. Despite the irrigation efforts, drought years were hard on farmers. In the late 19th century, some climatologists suggested a theory that rain would follow the plow, meaning that if a farmer was farming land, the rain would just come. This theory proved to be incorrect, as farmers were struggling through drought years and crops were failing, with the dream of a thriving and American West crumbling. In his exploration of the West, geologist John Wesley Powell realized that large-scale irrigation and water storage infrastructure was necessary to control both water scarcity and flooding. The infrastructure necessary to reclaim the West, he realized, was at a scale that only the federal government was able to provide. He also predicted that the overall settlement of the region was going to be limited by the general scarcity of water. In the early 20th century, the federal government took initiative. With the Reclamation Act in 1902, decades of reclaiming the deserts of the American West began. Congress authorized federal financing of water infrastructure, setting a foundation of an era of grand dam construction and ambitious water diversion projects. With heavy subsidies for water infrastructure, the big dream of a thriving West became reality. Now water indeed followed the plows and the settlers. The first big dam project following the Reclamation Act was the construction of Hoover Dam, once known as the Boulder Canyon Dam, a massive project, the largest of its time, and in fact, the American Society of Civil Engineers rated Hoover Dam to be one of 7 modern civil engineering wonders. Over 700 feet high, it dams the Colorado River in the Black Canyon, impounding Lake Mead. Located about 30 miles from Las Vegas on the border between Arizona and Mexico, Hoover Dam was built during the Great Depression in just 5 years. Hoover Dam was the first grand water infrastructure project on the Colorado River. It was built for water storage and regulation of flow to control flooding, and the ability to move water. Hydropower and recreation were attractive side products. Lake Mead holds about 2 years the annual flow of the Colorado River and thus provides substantial water storage in the area. Large dams like Hoover Dam, of course, have significant environmental impacts, and we'll be talking about these impacts in the remainder of the course. The first large federal canal project of the West was the All-American Canal, a 200-mile-long canal system in southeastern California. The All-American Canal diverts over 15,000 cubic feet of Colorado River water per second at the Imperial Dam near Yuma in Arizona. Its water is mostly used for irrigation in the Imperial Valley. Much of our winter vegetables in the US come from Imperial Valley, which is part of the Sonoran Desert that only receives 3 inches of annual rainfall, way too little for any crops to grow without irrigation. So let's fast forward to one of the more recent dams built in this era of dams, as people refer to the time of big federally funded water storage projects, the Grand Canyon Dam on the upper Colorado River. Grand Canyon Dam was built over 10 years, starting in 1956, and impounds Lake Powell. The main purpose of constructing the dam was to increase storage on the upper Colorado River and ensure water delivery to the lower Colorado River basin in drought years. Hydropower produced from the dam helps offset its construction and maintenance cost. Large cities across the West compete for the available water. Let's use the city of Los Angeles as an example of a city that's scrambling to develop its water supply. Already at the turn of the last century, the city of LA realized the need for additional water for its growing population, so they constructed the Los Angeles Aqueduct in 1908 to divert water from Owens River in the Sierra Nevada mountains about 200 miles to the north of the city. As population of Los Angeles continued to grow, they started to eye the Colorado River to increase its water supply. In the 1930s, the 240-mile-long Colorado River Aqueduct was constructed to bring water from the Colorado River across the Mojave Desert to Southern California. In this ambitious water project, the water is lifted at 5 stations over mountain ranges with a total lift of over 1,600 feet and through almost 100 tunnels. As Mark Reisner wrote in his book, The Cadillac Desert, water in the West does run uphill. It runs towards money. Between 1930 and 1960, the population of LA doubled again to 2.4 million people. Again, more water was needed. But where was water in the region that hasn't been tapped? So starting in 1963, the California Aqueduct was built to bring Sierra Nevada runoff to Southern California. Massive pumps are located at the southern side of the Sacramento River and San Joaquin River Delta and pump water towards the city of Los Angeles. But not just dams and water diversion infrastructure was built to redistribute water in the West. Water was pumped from one watershed to another. In fact, today, millions of gallons of water are pumped through trans-basin diversions across the Continental Divide to supply the Denver metro area and the Front Range communities. Trans-basin diversions mean that water that falls on the west side of the Continental Divide and would naturally flow towards the Pacific is diverted through mountains or across mountains towards the east side of the Continental Divide and now drains towards the Gulf of Mexico. These examples are just some of many water infrastructure projects. Rivers are dammed, diverted, and channeled at all scales in the West to maximize its reach. The Bureau of Reclamation alone manages over 340 dams. While many major dams produce hydroelectric power, enormous amounts of electricity are necessary to move water across basins as we do in the West, and to pump groundwater to the surface, and not all demands can be met by the hydropower available. For example, the water that's moved for the Central Arizona project from the Colorado River to the Phoenix area is pumped using energy that's supplied by the Navajo Generating Station, a coal fire plant emitting large amounts of carbon dioxide to the atmosphere. The view of water infrastructure and management has changed over time. Controversies around water infrastructure impact and dependencies on subsidized water have existed throughout the development of the West. Could it have been done differently? Today the best sites for dams are taken, subsidies are not as generous, and environmental regulations for dam constructions are much more strict. Today's challenges are how to manage water to supply its best use. Low river flow during drought years, declining groundwater reserves, and water pollution have to be managed, while population continues to grow in the West, adding further demands of water. Water scarcity and the availability of water under a changing climate is also uncertain. We'll hear more about this in the next module. One obvious solution is water conservation. Before looking where to conserve water, let's look at where water is used. The lion's share of water used across the western states is used for irrigation. Many innovative and adaptive solutions are being discussed and implemented in the agricultural sector, such as efficient water delivery, reduction of evaporation, and planting crops that require less water. Water managers are also looking to industry and residential users to conserve water through conservation strategies like xeriscaping of landscapes, as you can see in this image. Low water use appliances and toilets are being encouraged through incentives and building codes. But many states are still exploring new water sources and are discussing or planning new ambitious water diversion projects. For example, additional trans-basin diversions in Colorado to support the growing population along the Colorado Front Range, or ambitious and controversial pumping projects in Nevada to supply Las Vegas with groundwater from northern parts of the state. I hope this lecture gave you a brief overview of the enormous water infrastructure that was necessary to develop the western United States and is still necessary to supply the large population centers with this scarce resource. These large infrastructure projects have many environmental, financial, and legal implications that you'll hear more about in later parts of the course. See you next time!